All right, folks, this is more constant acceleration formula. Fun, fun, fun. We're going to look at the velocity function. So much fun. Okay. And it's not just the velocity formula, it is the velocity function because the car can only have one velocity at any given time. All right, so the velocity function, which you will get on the test, is that the velocity, which is a function of time, this is an infinite number of velocities, is equal to your initial velocity plus the acceleration, which is constant, times time, which is the input of your function. So this is a linear relationship, and so let's see what that means. Okay, so in Desmos, we have this velocity function with different sliders. So let's see what the effect of the sliders are. This is for whatever reason V1, not V naught, but notice that that is just your initial velocity, right? Just changing the y-intercept of the function. And so let's put that at 6. You can think of the acceleration as what am I going to add to the velocity to find the velocity that's true 1 second later. So if I add -4 to 6, what do I get? I get 2. So after 1 second, the velocity is 2. Now I'm at 2. What do I add? What happens if I add 4 to 2? Now I'm at -2. So at 2 seconds, I'm going backwards at 2. It's kind of hard to see the negative signs there. Okay, so that's what this means. That I don't think I can draw on this because I'm not really in Cami anymore. Okay, is that this is how much velocity I'm going to gain or lose every second. And since that is constant, for every second that you go over, you're going to go down 4. Over 1 second, down 4. Over 1 second, down 4. So the acceleration is the slope. So if the acceleration is negative, I have a negative slope. If the acceleration is positive, then I have a positive slope. We're not sure when we're going to talk about this in class, but one thing that is super, super helpful, I think we're not drawing velocity functions on the first test. We're just drawing position functions, but just be really, for later on, if you are in this quadrant, anywhere in this quadrant, the velocity is positive and you're going forward. Anywhere in the fourth quadrant, the velocity is negative and you're going backwards. And so in order to go from going backwards to going forwards for a split second, your velocity is 0, and that's your turnaround point. Okay, but again, I think only position functions are on the first test. Okay, I think I'll do maybe one more quick thing. So if your initial velocity is 8, then if your acceleration is -1, clearly it's going to take you 8 seconds to come to rest because you're only taking away 1 meters per second. And if your acceleration is 2, your slope is steeper and you come to rest sooner. Again, I like physics because there's a lot of things that are just self-consistent that relate to each other and that make sense. Okay, so output of the function, y-intercept, slope, input of the function. Okay, and then the last thing we're going to do is just see how this works in practice. So I would like you to pause the video. You are not just using this velocity function because that would just be plug and chug. And I know y'all know how to evaluate a function. So hopefully you're working in a space where you have all of your formulas with you. So pause the video, do letter A, check your work so that if you can make some corrections before moving on. Okay, so first, at some point I type this out, and it's neater, more neat handwriting. How fast is it going at t equals 2? We're going to learn something that I call physics Sudoku to kind of, now that we know, once we know all the formulas, will help you organize them all. But what do you care about? You care about how fast, and you do know the time. So we're going to practice the velocity function. It had a head start in speed of 4.8. It is losing speed, so that you have to put the minus sign in yourself. The word problems will not put the minus sign in for you for going forward or backwards, or for speeding up or slowing down. And we're slowing down going forward, so it is negative, okay? But be careful, because you know that's not always true, that the acceleration being negative is slowing down. Okay, and then how fast is it going 2 seconds later? It has slowed from a speed of 4.8 to a speed of 3.6 meters per second. So I hope you got that one right. So now do B. How long will it take to come to a stop? So interpreting the word problem, coming to a stop means V equals 0. And the question isn't clear how long from the last question or from the very beginning. So I think from the very beginning, clearly, I mean, this solution decides it is. So I started going 4.8. I'm losing this amount of speed every second. I want to go to 0. So how much time has to elapse? 8 seconds. Okay, and then how far did it travel? So now we care about location. That is the position function. I don't know why this x is wonky. So plug and chug. Often they don't tell you x naught is 0, so you just got to say that's got to be the assumption. V naught was 4.8. We found that the time was 8 seconds. Remember your negative sign. That's your time. Plug through that, and you get that it went about 20 meters, 19.2 meters. And then hopefully, again, these numbers are making sense. If I didn't slow down, I would go 4.8 times 8, and it would have been 38.4 meters down the track. But it didn't maintain that speed of 4.8. Every infinitesimal second there, and every infinitesimal time that elapsed, it was going a little bit slower, a little bit slower, a little bit slower. So that's why we're subtracting this stuff, and I only went 19.2 meters. So I'm still gaining ground, but at a decreasing rate. Okay, and then the last thing I have for you is use the fire drill formula to check your work. And so you can put this all in one equation as long as it's nicely documented. So we care about how far it went. It did not have a head start. And let's just plug that average velocity. It went from 4.8 to 0 in 8 seconds. So we're averaging, so don't divide by 8. It's initial plus final divided by 2, fire drill formula. That would be the average speed, 2.4, and it did that for 8 seconds. So you get 19.2 meters. Again, the point is, great way to check your work on a test if you have time, just to make sure that it's just nice to know, oh, I got the same answer 2 ways. That's looking good. Okay, so looking good, just like you. If we move this into play posit, let's just take a poll. Left over from COVID. Would you rather be a ninja or a pirate? You can make your choice and tell me why. Totally optional. All right, that is 9 minutes and change, and thanks for listening, and I'll see you in class.